Hello and welcome to Calculus tutorial. We have another derivative and antiderivative pair. This will be a breath of fresh air because this one is really easy. Because we already know the derivative. The derivative of e to the x is just e to the x. So the antiderivative of e to the x should be very, very easy for us to do as well because it's just the opposite. So what we know from last semester is the derivative with respect to x of e to the x is e to the x, so that must mean the opposite must be true for antiderivatives. So the antiderivative of e to the x is e to the x. Just don't forget your plus c. Nice and easy. So let's do a couple examples there and get this one done with. Practice that a little bit. Of course, it definitely looks more complicated here, but you'll see it's not too bad. With both of these, it looks like we are going to do some sort of u substitution. So what are we going to make our u be? Well, again, you're looking for the insides usually, and do a derivative in your head. Will it cancel out what's left over? So if I take the derivative of this one, you'll get 10x. Will that somehow cancel out the exponent? No. But this one will be 9x squared. That x squared will cancel out the other x squared. So you probably want to start with this. So du dx is 9x squared. And that means dx is equal to du over 9x squared. Plug all that in. 5x squared e to the u du over 9x squared. The x squareds cancel each other out, but the 5 over 9 does not. You can bring that to the outside. Times the integral of e to the u du, and that's where we can use our new property, and you get 5 over 9 e to the u, but plug back in your x's, and don't forget plus c. Hopefully that one is fairly straightforward. I think the hardest part is just making sure you can find what u substitution to use. Alright. And now, some with some trig functions. So again, what u do we want to pick? Probably the exponent is another safe bet because we need that to be a single variable. So our u substitution will be tangent, it looks like. Let's see if this works. Du dx. Derivative of tangent, it's probably been a while, is secant squared. And then dx will be du over secant squared. Good reminder of what that derivative is. It's probably been a while. And you can see that this secant squared is going to cancel out that secant squared. And it'd be kind of nice. Why don't we shorten this? Do that in your head. So the secant squareds will cancel. We'll have e to the u du left over. And so that antiderivative, oops, I don't need the integral symbol anymore, will simply be e to the u, which u is tangent, so we'll just turn that into tangent x. And don't forget your plus c. And of course, if you did the derivative, you can see the chain rule there. Hopefully you can also see how the secant squared would come back if we did the derivative of the outside times the derivative of the inside. Well, that's pretty much all there is to it. It's just another thing that we have to remember for derivative and integral pairs. Thankfully, that one's a bit easier.